In this video, we're going to be talking about chi-square. Chi-square is a test of significance for a crosstab. So because chi-square is a test of significance, it is following hypothesis testing. And so we're going to follow the 5 steps of hypothesis testing when using chi-square. So similar to a t-test or an ANOVA, chi-square works in the same way, but this time instead of working at a numeric variable and a nominal variable, we can do 2 nominal variables or actually any combination of levels of measurement. So because we're following the 5 steps in hypothesis testing, we're going to start with a research hypothesis and null hypothesis. Then we're going to compute the value of a test statistic, in this case chi-square. Then we'll calculate the degrees of freedom. Then we'll look up the critical value in the table, and then we'll decide whether to reject or fail to reject the null hypothesis. Step 1 is to specify the research hypothesis and the null hypothesis. So here we have 2 variables. The independent variable is sex, male or female, and the dependent variable is whether you find life exciting or dull. So one possible hypothesis might be that if you are male, then you find life more exciting. And then for our null hypothesis, we have our no relationship hypothesis, right? So our null hypothesis, or HO, would be that there is no relationship between sex, and finding life exciting. So now that we have our hypothesis and null hypothesis to kind of guide our statistics, we can move on to step 2, which is actually calculating the chi-square. Now, before we move on to calculating the chi-square, there's something I want to bring up that we haven't talked about yet. And that is type 1 and type 2 errors. So whenever we're deciding on a probability level, so I always tell you guys to use the alpha level of 0.05, but there are other alpha levels that you can use, specifically 0.01 or 0.1. And those alpha levels give a bit of confidence. So remember in our confidence intervals, we talked about the 95% and the 99%. Well, there are 2 types of mistakes or errors that we can make when we're doing hypothesis testing. And the first type is type 1 errors. This is when we reject the null hypothesis, but there really is no association. There's no relationship between the 2 variables. So we wrongly say that there is likely to be a relationship when there's really not. And a type 2 error is the reverse, where we fail to reject the null hypothesis when there really is a relationship between the 2 variables. So the alpha level changes which you're more likely to make. So you're more likely to make type 1 errors where you reject the null hypothesis, but there's really no association. The larger your alpha. So if alpha is 0.05, you're more likely to make type 1 errors than if it's 0.01. But you're more likely to make type 2 errors when your alpha level is smaller, say 0.001. So you have to kind of balance which errors you make with kind of how exact do you want to be. And so this is why we typically use 0.05. 0.05 gives us a nice balance between type 1 and type 2 errors and the likelihood that we'll make each of those. So now we get to step 2. We're going to compute the value of a test statistic for the relationship. So the one that we're going to be using is chi-square. And chi-square is notated with an x squared. And it has 2 components, of course, just like any test statistic. There's the actual test statistic, chi-square, and then there is the critical value that we look up in the table. And you have a table that is posted here on OpenClass that will give you that critical value, just like we had with the t-test and with ANOVA. So the formula for chi-square looks like this. Chi-square is the sum, so adding up all that comes after it, the f of o minus f of e squared divided by f of e. So remember here, the f of o represents the observed frequencies in a crosstab. So remember, in a crosstab, each cell has a frequency in it, along with the percentage. So that f of o is going to be the frequency in the cell. And then f of e is the expected frequency in that same cell. So the expected frequency is the cell frequencies that we would expect in a crosstab where there's no association, no relationship between the two variables. So on the next part of this lecture, I'm going to show you how to calculate the expected frequencies, and then we will actually calculate a chi-square and interpret. So that'll be in part 2.